Part 3, I promise that this will not happen next week. I will figure out what in the heck is going on and why it keeps cutting me off. But anyway, what I was saying at the end of part 2 is that y always comes first and then x. Y always varies directly as x. So y always comes first. So when you're reading these word problems, the y is going to come first. So this says the amount of money spent varies directly with the amount of minutes. So money came first. So money is our y value. Minutes came second. Minutes is our x value. So if you talk on the phone for 100 minutes, so that's minutes. We said minutes is x. So we know that 100 is going to equal x. I'm going to write that over here on the side as well. And spend 25. $25 is a type of money. So money was y. So y equals 25. How much will you pay if you talk on the phone for 500 minutes? So this is x because we said minutes was x. How much will you pay is a type of money. So we're looking for y. So this is going to be similar to number 4 up here. Just it's a real world problem. So we're still going to use the directly. So y equals kx. So in this case, we have to find k first. Just like we did here. We found k first. So y is 25. We don't know what k is. 100 is x. Divide by 100 on both sides. We get k equals 0.25. So what that means is that we pay 25 cents for each minute used. So trying to figure out how much we're going to pay, we use 500 minutes. We're going to have y, because that's what we're trying to find, equals 0.25, that's our k, times our x, which is 500. Y is going to be 0.25 times 100 is going to be $125. Okay, looking at number 6. The amount of calories burned varies directly. So that means we're going to use y equals kx with the hours of exercise. So now first we have to determine what's our y, what's our x. Y always comes first. So the amount of calories burned. So calorie is going to be y. With the hours of exercise. Exercise is going to be x. So Emily exercises for 2 hours. Exercise, x. So that means 2 is going to be our x. And burns 500 calories. Calories, y. So y is 500. For how many hours? So how many hours? Hours is a type of hours for the exercise. So that's going to be, we're looking for x. If she burned, we're given y. So this is going to be like number 5 is like number 3, sorry. Number 6 is like number 4. So we have to find k first. It's always our first step. So we're going to use these two values, 500 equals k times 2. Divide both sides by 2. I'm going to get k equals 250. So this means that she burns 250 calories every hour she works out. So how many hours did she work out if she burned 1,000 calories? So using the equation y equals kx, y is going to be 1,000. K we just found to be 250. We're trying to find x. We're trying to find how many hours she worked out. So divide both sides by 250. I'm going to get k equals, not k. What am I thinking? X equals 4 hours. That means she would have to work out 4 hours to burn 1,000 calories. That is crazy. All right, last one. Hopefully no part 4. Fingers crossed this thing doesn't shut off. Okay, so just like a regular line, you can represent it in a table with its x values and its y values. This is just a point on the line. So there's a point -3.6, a point -1.2, and a point 2, -4. So we have to figure out, is this a direct variation or not? So 2 ways you can do it. One way, put it in Desmos, put the table in, see if the table when you graph it, does it go through the origin? If it goes through the origin, yep, that's a direct variation. If it doesn't, then it's not a direct variation. The other way that I'm going to show you on here is using math. So determine if each table represents a direct variation. So remember, y equals kx. That means we have to find the constant of variation for each point in the table. Constant. Constant means it stays the same. So you have to get the k value to be the same for each point. So here's point number 1. So we're going to use y equals kx. Our y value is 6. We don't know k. Our x value is -3. Divide both sides by -3. We get k equals, or -2 equals k. That's our k for that point. Checking the second one. Still using y equals kx because we want to check to see if it is a direct variation. So you have to use that formula. So our y value is 2. We don't know what k is. Our x value is -1. Divide both sides by -1. We get -2 equals k. So far, they match. But we can't say it's a direct variation yet. You have to check all the points. So on this one, using the same equation, y equals kx. Y is -4. We don't know k. X is 2. Divide both sides by 2. -2 equals k. So yes, these all three have a k value that is the same. So that is a direct variation, meaning when you graph this or put in Desmos, it should go through the origin. Looking at number 2, y equals kx. Checking the first point. The y value is 7. K value we don't know yet. 3 is our x. Divide both sides by 3. We get 7/3 equals k. All right, let's check the next one. Still using y equals kx. Y is 11. We don't know what k is. X is 5. Divide both sides by 5. 11/5 equals k. This is obviously not the same thing. If you're not sure if they're the same thing or not, you can always check to see if their decimals match. But I'm going to say, nope, these don't match. So this is not a direct variation. Meaning, if you graph it, it's not going to go through the origin. It's going to go through some other point. I am going to stop there. You can figure out for yourself if that one's a direct variation or not. If you have any questions at all, please feel free to reach out to me. And next week, I'm going to try my best not to have the videos break up into 3 parts. Have a great time, and I'll see you all on Thursday.